Welcome back to the part 6 of this series. Until now, we were able to access the application internally using the internal domain or the cluster IP. Now it's time that we expose our application to the external world. And for that, we would be configuring Ingress. Now, this video specifically focuses on Ingress for the appliance RTF. Now, this doesn't mean that none of the concepts would be useful in other flavors of RTF for the ingress configuration, but it's just that couple of configurations, these are only specific to appliance RTF. So in case if you're looking to understand or configure RTF for BYO ingress for BYOK RTF, then this video might not be for you. With that, let's get started. All right, so this is the current topology of the RTF cluster that we have created. Right now we have worker A and worker B and a controller node. Now, in case we want to access any pods, we can directly access the pod using either the pod IP or the cluster IP service. But in case if we want to access the pod from outside the Kubernetes cluster, it's not possible, right? It can be accessed only within the cluster. So in case to access outside the cluster, we would need to set up ingress. So this is how the topology would look once we install ingress. So in the appliance model, we have already have an ingress available. All we have to do is just configure that. But if you do not have an appliance model, then you'll have to create the ingress on your own. In case of appliance, all you have to do is just upload a TLS certificate with correct domain name, and then you're good to go. So in the appliance model, the Ingress controller is a homegrown product by MuleSoft, and it can handle all the routing requests. It's not Nginx, but it's a MuleSoft created product. It's also called as Edge. All right. Now the Ingress sits on the controller. It's deployed on the controller node. And in the diagram, if you observe, the ingress is capable of getting the request from outside the cluster. So any request coming on port 443 for HTTPS and port 80 for HTTP can be served by ingress. So there are multiple options available, whether to use HTTP or redirect HTTP to HTTPS. We'll explore them in the hands-on part, but right now this is how it looks. So the ingress can be called from outside the Kubernetes cluster, and it can it's you can think of an ingress as a layer 7 load balancer. So basically all the requests that would come to it, uh, ingress is capable of doing the TLS termination at its own end, and ingress will expose its own certificate. All right. Now, the ingress cannot will not directly call the pods using their pod IP address, but it would rather leverage the service. So we have seen that each Mule application that gets created has a cluster IP service created for it, right? So in that case, the ingress controller will have the mapping rules, and those mapping rules will basically map the request to the cluster IP service. So if I scroll down, here's how it looks. Anyone from outside the cluster, since we create a certificate with a common name as the domain, so this is the domain, then the URL for an application would be of this form. So there are two possibilities. In case if the there is this only there is no wildcard domain, then this is how the URL gets created. Let me show here. So the common name, right? If the common name is not a wildcard, for example, if the common name is simply vpdemo-rtf.net of this sort, there's no wildcard in here, then the URL for your app would be the common name or the domain / the app name. But in case if the common name has wildcard, For example, if it is cn equals to wildcard means star dot vp demo rtf dot net, in case if the common name is in this form, then this URL would change to something like this. So the app name comes first, rtf hyphen test hyphen app dot the domain, and this gets removed from you. So this is in case of the second one is in case of wildcard, and the first one is in case of normal. All right, so this is how the URL would be found based on the common name specified on the TLS certificate. So the request comes to the ingress. The ingress controller will then route the request based on the cluster IP service or the internal domain that we have configured. Now, one important thing that you should remember is that the ingress, whenever it routes the traffic, it defaults the protocol to HTTP and the port to 8081. So if you have any application listening on port other than 8081, then the ingress won't be able to route the request. Also, the protocol on your application mule app has to be HTTP. In case if your application listens on HTTPS protocol, in that case you have to make certain changes, and that changes can be done by via the runtime manager. So what usually happens is the traffic, the journey from service to our mule application spod is basically termed as last mile. So whenever you want to use HTTPS on your own Mule application, you'll have to enable last mile security. With help of this, the traffic from the service to your application would be in HTTPS protocol. The ingress would make sure that it adds a routing rule that it has to use HTTPS. And the port will always be 8081, so make sure that you use 8081. Now, does that mean that 8081 is mandatory? No, not at all. If you do not want your application to be exposed to the external world via ingress, you can always choose a port of your own choice and then can use the internal domain along with the port. That should be fine. But if you want to use via ingress, make sure that your app listens on port 8081. The other important thing that you should notice here is that the TCP connections. So whenever you have someone calling the ingress, there's a TCP connection established from the client to ingress. Now ingress is a layer 7 load balancer, which means that it will terminate the TCP connection and create a new TCP connection from itself to your application pod. So if you see, there are two TCP connection. This is one from client to ingress and the other one is ingress to the pod. Now in this diagram, you are seeing service to the pod, but basically it's from ingress because ingress will initiate the connection to service, right, and to the pod. So the connection is from ingress to the pod. So basically there are two TCP connections involved. So make sure that whenever you are trying to route the traffic to ingress, there's no point of having HTTPS listener on your application pod because ingress takes care of it, right? And it's helpful from maintenance point of view also. For example, if you happen to change the certificate since it's expiring or something of that sort, you should be changing the certificate at one single point rather than changing the certificate on each app, right? That could be hundreds of app and changing that would be quite difficult. So instead, you have a single point and you change it there. So you can consider not to use HTTPS when, at least in your Mule application, when there is already a TLS certificate installed on the ingress, because you'll have again, there's you cannot get rid of this two TCP connection, but what you can ease out here is the unnecessary encryption, right? You're already inside your internal network, then why do you need encryption? You can use plain HTTP protocol. Now, in certain special cases, you might want to establish two-way SSL for certain applications, right? So, not on all, but on certain application. In that case, you need to get the certificate of your client. But in this case, by the default procedure, the certificate, even if you enable two-way SSL, the certificate of ingress would be visible and not that of a client, right? So in that case, you can continue using HTTPS on your own pod. Last mile security has to be enabled, but along with that, you have to enable an option of forward SSL. So in that case, the certificate of the client would be forwarded to the Mule applications pod, right? So then the two-way SSL can be established. So these are a couple of points that you should notice and be aware of because when it comes to performance, these are the places that you might try to improve. Also, the other thing is that if you are doing internal communication, if your application on worker A has to communicate with worker B, right? So internal communication between the Mule app, then never go through the ingress because it's like you go outside the cluster and then come inside the cluster, whereas you can directly reach each other, right? So in that case, consider using the cluster URL rather than the ingress URL. But in case if there is a special use case, then it's okay to go via the ingress. But normally, or in most of the cases, consider using this cluster URL. All right, so now it's time for some hands-on. We'll start by creating a TLS certificate and then configure the ingress and let's try that out. Now, in order to create a TLS certificate, we need to create a new key store. So for that, you can download this utility Key Store Explorer and install it. Once you install it, it will open up and you can use the create a new key store option. Click on JKS and here let's create a new one. So we first create a key pair. So the algorithm will go by the defaults RSA and the key size as 2048. Now let's select the default. Signature is SHA 256. Validity is for 1 year. Now let's edit other parameters. So common name will be the domain name. So let me give as vp demortf.net. Doesn't need to be a real world domain. You can give any domain. It just has to be a valid domain name. Uh, then the organization unit. Let me enter it as delivery. Organization name, my company, locality, local, state, country. Click on OK, alias, and let's give the password as password. Let me confirm this. And the key pair was generated successfully. So it created a public and a private key. It's time to export. So I'll export the key pair. All right. And the password for this file, I'll keep it same. Password, password. And the key pair has been exported successfully. In the platform, we need to apply the certificate. So in the RTF, let's go to inbound traffic. Let's enable inbound traffic. Now resource allocation. As we know that ingress has two parts, controller and the resource. So resource will have the mapping rules, but there has to be some controller who can route the traffic. So the controller, since this distribution is an appliance distribution, the controller, the ingress that is here, we do not do anything. We just have to apply certificate on it. And the controller is basically a MuleSoft product, a homegrown service that works behind the scene. All right, so The replicas, by default, it's one replica. We don't have an option to modify this, but we can modify the cores and memory. Right now, we'll go with defaults. Protocol will keep it as HTTPS. Anything coming on HTTP will be redirected to HTTPS. All right, now let's add the domain. Click on Add Certificate. There's no option of PKCS that we just exported, right? We have PEM and JKS, but the export that we have completed is of PKCS. So no problem. Let's go back to Key Tool Explorer. Let's export it again. And this time around, I'll export it as PEM file. Use the password as password and export it. Okay, it has been exported. Let's go back to platform. Now I'll select the public certificate. So I've imported the PEM file. It shows me the expiry and the domains. But there's an option of private key as well. Okay, I'll have to change this again. Let's go back to the key store explorer, right click, and I'll separately export the private key and the public key. So let me just export the private key. Let's select the PKCS. Password is password. All right, let's click on export. Now back to the platform. Select the key. Okay, so I have imported the private key. Let me enter the password. Now finally, let's click on Add Certificate. Once that is done, we can always check the details by clicking on this, and we see that all the details are coming up correctly. So let's click on Done. Now, apart from this, we have advanced option, which I won't be modifying it, but I'll go with the default values that are there. So it has max connection, so the number of connections that can be established, requests per connection, idle timeout, and all the different configurations are there. You can modify based on your requirement. Once this is done, let's click on Save and Deploy. Okay, so it says request sent successfully. Let's wait until it's applying. So we see that it's container edge. It's creating the container. Let's go to Putty and log into the server to check if it's creating some pods. kubectl get pods hyphen hyphen all namespaces. We don't see any pod right now. Let's see kubectl get ingress. There's no ingress there. Okay, but it says it has started successfully. So looks like the ingress has been applied successfully. Now we'll have to check uh, if the ingress is created or not. So let's find that out. Okay, so now if we carefully observe the pods, we see that there is an ingress pod created, right? It with the name as ingress in the namespace RTF. And the status is running and it's 3 minutes 27 seconds. So it means that ingress has been applied successfully and we can try deploying our apps and they'll get a new URL using which we can access it externally. Externally as in outside the Kubernetes cluster. Now it's not necessary when I say externally, it means that I can access over the internet because the domain that we have used, it's not registered on any public DNS. So most likely that domain won't work. But internally, if I try to call with that domain, basically from this node, it should be able to work. So let's try that out. So in the platform, I have the app created already, right? And the application URL is not enabled because there was no ingress. But this time we have the ingress. So if I scroll down, you should be able to see this ingress tab enabled. In the previous video, it was disabled. So if I click on it, it gives me a public endpoint. So this endpoint can be reached via the public internet. Available domains come from the runtime fabrics configuration. So the domain comes from the common name that we give while creating the certificate. So if I click here, I can see the common name appearing. Now this gives a URL. So it's giving us the name and forward slash the application name. So domain forward slash the application name. There are a couple of other options available. It's the ingress options, forward SSL session, and last mile security. So the last mile security means that we have this ingress on it on here, which is on the controller node. Now this ingress will do a TLS termination based on the certificate that we have provided. And after this, the other call that is going to happen from the ingress to our application pod will be without HTTPS. It will be plain HTTP. But in case if you are using HTTPS on your application, in that case you need to enable last mile security so that ingress won't default to HTTP but rather use HTTPS for the traffic from ingress to your application pod. And if you want to forward the SSL session, in case if it is two-way SSL, so you want the client certificate to reach your application pod, you can enable this option. Right now, this app that is currently deployed is only HTTP, not using HTTPS. So we can basically disable, we don't need this at all. And the traffic from client to ingress would be HTTPS, but from ingress to the pod, it will be HTTP. So with this, let me quickly apply the changes. So once I apply changes, I can see application URL is created here and it's up the configuration. We can also check the history of the applied configuration from here, what had been applied so far. Once this configuration is applied successfully, we should be able to reach our application using this endpoint. Now, remember, this is not a public URL despite this point saying, right, the public endpoint. It's because I haven't registered this domain on a public DNS. So it won't work on the internet. It will basically uh, work from my node. If if in case you have a domain which is publicly registered, it has to be registered to the controller's IP, right? And which basically means your controller needs to have a static public IP, and in that case, you can access it. So now that it's applied, uh, let's go to the server and I'll try to call this. So I'll use curl hyphen lvk. Now I'll have to use lvk because there's a certificate, so it might give error because it's a self-signed certificate. Let me use https vp hyphen demo hyphen rtf.net and vp demo rtf app. Okay, it's not working this way, most likely because we are on the node. Let's enter gravity. So let's do gravity enter, and there it should work most likely. Okay, now let me do a curl. Let me simply copy this and paste the command. So even this one has failed. Now, what could be the reason behind this failure? Let's try one more variation. Now this time around, I would directly use the IP address of this controller node. So I'll use curl hyphen l vk and add a host header, it as host. And inside this host header, I will give the domain name vpdemo-rtf.net Then HTTPS IP is 10.0.0.44 forward slash app name pp demo hyphen rtf hyphen app. Let's hit enter and I get the response. Let's copy the same command and get I outside the planet container. All right, and exit enter. I am outside the planet container. Let me run that command again, and I can access the pod right now, right? I am getting hello world response. But why was it not responding when I used the domain as is? So the reason is quite simple. You see that this is an ingress, and this ingress is using a certificate which has a domain on it, right? This domain is basically an external domain which gives access to someone who is outside the cluster. So what's happening here is that there is no DNS entry created, neither in the node's DNS server nor in the pod DNS, which is Cube DNS or the Planet Containers Core DNS. There are no entries created, right? So in that case, if there is no DNS entry, the the host won't resolve to any IP address. So we cannot use this host name. So the only option that we have in this case is we have two options actually. First, we either add this DNS entry into the node's DNS server. Okay, we cannot edit the DNS, go and edit the DNS of Planet Container. We won't do that. But what we can actually do is edit the DNS for the nodes. The DNS server is sitting on 10.0.0.2 in this case on AWS. I can try to modify that. Alternatively, I can get this registered on a public domain, which would incur me charges. Otherwise, this IP, right? It has an internal domain. Whenever you deploy your applications on, you create an EC2 instance on AWS, you get an IP address, you get a domain name associated with that particular IP, and which is basically an internal domain. For example, we have right mule worker internal and the app name. On the same lines, there is an internal domain that AWS creates for every EC2 instance that gets created, and that domain name is internal. That means that you cannot access from the internet, but you can access within the VPC or your AWS system. All right. So the other option would be to go to the Key Store Explorer and create a new certificate with common name as the DNS name uh, given for the EC2 instance. So let's quickly make those changes and see if it works or not. Now, in order to change the domain, I'll end up creating a new certificate, but that's fine. We first need to know what is the domain name. So for that, I can go back to AWS console, and this is the private IP DNS name. So we can basically use this as the domain or as a common name while creating the certificate. But first, let's validate if this works or not. So I have the curl command, right? Curl command. I all I need to do is modify this IP address to this host. This works. Yeah. So this works. Now you might be thinking that if it works, then why do I need to create a certificate? The reason I need to create a certificate because now if I'm trying to call it, I need to specify the host header. If I do not specify the host header, it doesn't work. What is it giving? Okay, it gives some error with curl command. Let me fix this. What was the curl command here? So let's just remove this hyphen. And you see, I am not getting any response, right? So where is the command? This was, okay, this is the place where it started. So it's trying, and it gives 4, not 4, because I haven't specified the host. The reason why I have to specify the host here is that because I am basically not using the domain that has been assigned to a certificate. So whenever the request is going to the ingress controller, it tries to check with the domain. It realizes that the domain is different than what is present in the certificate. So it doesn't work. But when I give the host header, it basically relies on the host header. So what usually happens, to explain, here is the URL, right? So what usually happens in HTTP is that this particular DNS will be replaced by IP address. Okay, so since the IP address has replaced, someone has to maintain this domain, right? So what happens behind the scene, automatically a host header is added. So inside the host header, this thing will be added as a host. Now, there's no host named as, I mean, a machine can have multiple web servers, right? And each server might be serving some different web pages, right? So for that, you need a domain, right? For example, one app is on domain VPRTF demo, other app could be on domain xyz.demo.net, right? So the domain has to be there. So what we have done in this case, it doesn't work because in the host header, this will go as a domain, but on the ingress, there is no such domains. On the ingress, the domain is VPRTF demo. So what we do, we explicitly mention the host header as VPRTF. So what the curl command will do behind the scene, it will just replace this with IP address, and it won't be replacing the host because I have explicitly mentioned the host header. So that's the logic behind the host header, right? Now I don't want to pass the host header, but I just want to have this internal domain and get the response. So for that, I'll again have to modify the keystore and create it with a new domain. So I'll quickly do that. So back in Keystore Explorer, let's create a new certificate. Let's choose RSA. Now this time around, I'll give the common name as this value. Let me get the exact value. It's this. Okay, let's go back, paste it. Organization unit. Let's give all the same values that I've given previously. My company, locality, local. Let's click on OK. Okay, let's give the same password. Password. Okay, so key pair generated successfully. Time to export. So let me export key pair. I'll export as spam password. So the same steps that we have done previously, it's just that I'm doing it with the common name. Let me export the private key as well. KCS8. Okay, so everything is exported. Now let me go back to the management center. I'll open RTF. So inside the RTF, let's go back to inbound traffic. Let me delete this certificate and instead add a new certificate. So this is the file that I created, vpdemonet. Oh, this is not the one. I think this is the one. Yeah, this is the PEM file. Let's select this, right? Let's get private key again. Now I think this is the private key. Let's click on open. Okay, so I see the private key. Time to give the password. So I went added the password. Let's click on add certificate. And I see that the certificate is added. Now it's time to save and deploy again. So let's click on save and deploy and go back to the node. And this time around, the pod should be undergoing some changes. So kubectl get pods hyphen n rtf o wide. So I see the ingress is still running. Should change. Let's go back to okay. It has successfully applied. So I think there wasn't any downtime and it applied on the fly. So the ingress pod is still running. It just changed the certificate. Okay, let me try to hit this. Still not working. Has it been applied or not? Let me click on this again, save and deploy. View details. It shows it has applied successfully. Hmm. Hmm. Now it's working fine. It's now in terminating state. So it will basically spin up a new one. I think previously it wasn't applied correctly. So this should be up in a couple of minutes. Shows that it's running. That's it. So it's starting container edge. Let's give it a couple of moments. Okay, now it's running. It's applied. Now let's see the moment of truth. Oh, didn't work. What's the error? Says 404 not found. Let's try again. I think the host name is correct. VP demo RTF app. This is a certain common name. Why is it not working? I think I might have to restart the app in order mm, for the effect for changes to work. So let me stop this and start it again. Okay, the app has been stopped. Let me start now. Okay, the app has been deployed successfully. Let's try again. Hopefully it works this time. Didn't work either. Okay, so let me try again with adding the host header. Let's see if I get any results. So I've added the host header and let's go with the old one. Let me try this and I am getting the response. So what is the mistake that I have been doing so far? Let me go back to platform. And in here, if you see that the domain is still the old domain, right? So it has to be changed. So now I see two in the list. Now this would get removed once I select the other one, but this is where the problem was. The application URL was still the old one, and that is why the ingress resource rules were not changed, right? It was having the wrong domain. So now let me just change this, apply changes, and it should get applied. I see the application URL has changed. Let's see how long it takes. Okay, so the changes have been applied. Let's go back. Hopefully now it should work. We have already spent a lot of time figuring out the mistakes, but yeah, it's good to make mistakes. At least we know what's going on. Now, hopefully this time it works. Cool. So it worked, right? We are getting the response, and the certificate is the one that we created. So we are finally getting response, and we were able to apply the certificate on top of Ingress. And that is how we can access this externally. Now I cannot access it over the internet uh, with at least with this domain. I can continue to access it over the internet. The only thing that I'll have to do is that I'll have to get the public IP of this EC2 instance and make sure that uh, why not just try it? Okay, so what I'll do is I'll just in the EC2 instance, this is the public IP address. Now I'll have to modify. Let's see if I'm able to hit this or not, first of all. Okay, if do I have telnet on port 443? I do not have telnet on this machine. Okay, but let's try if I can do a curl https hyphen lvk 404 not found. So I already have 443 open. What I can do is now this is the public IP address, right? So I can continue using uh, this is a common name. Let me use this. So now I'll have to add the host header. It's because there is no public DNS entry. Right now I'm trying to access through the public IP address of this node. So 10044 as this as a public IP address. So let me give the header host header, and I'll paste this and the path. So the path should be vp demo rtf. Where is that path? I'll manually enter it. vp demo rtf. Saying 404 not found. Let me just go back to platform and check the app name. Okay, so the app name is vp demo rtf app. This is where I was wrong. vp demo rtf. I need to add app, and I'm getting the response. So you see, I'm able to access using the public IP address, which means I can literally access from the internet. Had there been no ingress, in that case, I wouldn't be able to access over the internet. But since right now I have ingress and ports 443 and 80 are now open, I can access it. I'm not able to configure vanity domain over the internet. It's because I haven't registered any domain on the public DNS. But in case if I'm able to, uh, basically it would be a charged service. So what I'll have to do the next step is go to Route 53 uh, and get a domain registered with this name, because this is what I've given, right? So I'll have to get the domain registered. If you want your own domain, vanity domain, you know what to do, right? Now you'll have to go back to the certificate, give your own domain, custom domain name as the common name, and then get that domain registered to this particular IP. Make sure that this is your static public IP. Only then it makes sense. If this keeps changing, there's no point, right? So you need static public IP and a domain registered with that static public IP, and it has to be on the public DNS server, which again is a charged service. Now let's check the ingress that we have created. To check the ingress, I'll have to type the command kubectl in get uh, ingress hyphen all namespaces. Previously, what we have seen was the ingress pod, which is basically the controller. But now let's check this resource. So we see that there is an ingress created, a resource of type ingress is created, which has this name, and the namespace is the environment ID, and the host that is being provided in the certificate's common name. Port is 80. All right. Now let's try to describe this. So kubectl describe ing. I'll give the name and the namespace. Hyphen. So it gives a description, the host, the path, and the backends. Right. So right now I have only one application deployed, and that's the reason I only see one backend. So if there are multiple apps, you will get multiple paths that are configured. Now you can also get a detailed YAML file for this that's used to create. So we can use kubectl get ing. Again, the same thing, name and namespace, and use OYAML. So it shows you the YAML file that was used to create. Now here in the rules, you see that there is a rule added. Service name is VP demo RTF app, service port is 8081, and path is this. So if there is any request coming with the path as this, it moves to the service. Now this in turn proves that whenever we call via ingress, the ingress basically uses the service. So what service do we have on our Mule application that is deployed? It's a cluster IP service. So it will try to reach out the cluster IP service. Let's validate this. So what I've done, I have redeployed the Mule application, and it will print now or return all the attributes that have been sent in the request, or the application that receives all the attributes. So it will have all the headers, the query params, and everything. So let's test that out. So I'm using the same URL that we used previously. I'm trying to access it via the public IP address, and that's the reason I'm giving the host specifically, because I do not have any DNS entry and public DNS entry for this particular host. So let's hit enter, and I get the response. So what I've done is I've added an attributes part, and the existing hello world remains as is. So if you observe in header, we see user agent as curl, but it has come via Edge 1.1 MuleSoft. It means that the the ingress is sitting between uh, my curl command and the Mule application. So it has come via Edge MuleSoft. It is showing forwarded for, so it's forwarded for 18141 1110. This is a controller IP, and since I triggered this request from this IP, it's literally showing me that this request has been forwarded for someone. So this is the original requester, which is me. Then we have the forwarded host. So this is the host to which the request has been forwarded. So the common name of our ingress. Then the protocol was HTTPS. And finally, the actual host. So this again proves, right, that the request goes to the service, cluster IP service, rather than going to the pod IP address. So this is the same VP demo RTF, which is the app name, then the namespace, which is the environment ID, and SVC cluster local. Now, if you observe a couple of other things, which is a local address. So the local address is 10.2.44.6.8, and remote address is 10.244.60. Now let's try to find out what is this local address, whose IP it is. Now this IP will most likely be the IP of this demo app, but let's just validate. So I'll use kubectl get pods hyphen n. Let me use the namespace and validate. I'll copy this void. Okay, there's a typo. Let me fix it. All right. So if I see this is the pod IP, this is the node IP. Node IP means the worker node's IP, right? But this is the pod IP 10.244.6.8, and this is exactly what is the local address, right? So the remote address. What is the remote address? Now the remote address ideally should be that of the ingress, right? Because ingress is sending the request. Ingress is acting as a middleman for me and it's sending the request. Now let's try to find this out. Who has this IP address? So for that, I'll again run kubectl get pods hyphen all namespaces because now I don't know who has this, right? Get all namespaces hyphen o wide, and what I would do is I would add a grep on this IP address. But let's just keep 26. Let's see if how many IPs have with this. Okay. So if I add a grep, I see that 26, 3, 6, 2, 9, 15. So basically, I don't have any such IP. So could it be on the service? Well, let's check that out. kubectl get svc instead of pods. Okay, there's no service either. So if we remember, the services usually start with 10 100 because that is what we have set in the while configuring this cluster, right? So it's all 10 100 series, right? So it's basically not among the pods, not among the uh, services, right? So where does it actually comes from? That's the question. This is completely different IP address and we could not find it. All right. So to figure that out, what we can do is we can try to check the ifconfig. Let's see. So in ifconfig, again, let's run the grep command and paste this. All right. So I see there is one IP address, right? Where is it? Let me check in this list. All right. So it belongs to this flannel, right? 10.244.26.0. Okay. Let's again check the root as well. So if I check the route, I see this is the destination 10.244.6, gateway is 10.244.6, 255 is the subnet mask. So and it's assigned to interface flannel 1. So what does this means? This means that whenever you are trying to get inside the pod network, this is the gateway. So you have to come through the flannel gateway. And that is the reason the remote address, right? The remote address comes to be the flannel gateway instead of the IP address of the ingress pod. If I check the ingress pod IP address, let me run kubectl get pods hyphen all namespaces. All right, where's the ingress pod? So this is the ingress pod, right? Let me get the IP address hyphen o wide, and this is ingress. So what is the IP address? You see that it's the IP address of the node. It doesn't have an IP address from the pod network, right? So it should have the remote address should have got 10.0044, but no, it didn't get because from the node it's going through the to the pod network, and it reaches the pod network via this gateway, which is at 10.244.26.0. So all the pods, right? If they want to communicate with each other, this is the gateway that they have to use, and it belongs to the container network interface. Now, what about trying to enter the by let's use the cluster IP service to call. So to call that, I'll use this. Okay. But to use this, I would have to enter gravity. So instead, I'll use a pod IP address. This should get my job done, right? Now let's do a curl hyphen lvk https. Enter this. It's taking time. Okay, I see that I'm not using HTTP in the app, right? So this HTTPS is to go via ingress. So I'll have to change the protocol. Let's use HTTP. Okay, now I'm getting the response. So in this case, the remote address still remains the same. It's via the gateway. But what changes is that we don't have forwarded for an agent thing, right? We have the user agent, but we don't have it's forwarded via, right, the edge runtime, because it's there's no ingress here in between, right? So that's the reason we don't have all those values. But what we do have is a remote address which remains the same, because eventually it went through the gateway, right? So it will have that remote address, and the local address remains the same. So that's the difference. Now, if let's see, let's try other variation, which is going via the cluster URL. So since it's inside the pod, right? That DNS entry for this value. Where is that value? If I scroll up, yeah. So the DNS entry for this value is in the cube DNS, right? So I'll have to enter the cluster. So let's use gravity enter. Remember, uh, this command should run. Okay, I think I am already inside the gravity container. All right, I wasn't aware that I was inside gravity container. Let me run the command then right away. So this gravity, the planet container, right? It's accessible only in case if you have the uh, appliance flavor of RTF. So do curl. Let me run the same command and just paste it. This time around, it will be HTTP because I'm not going via ingress. I'll have to specify the port. Okay. What do I see? I see the same result. Now, if I'm out of also the this values of headers remain same as the previous one. It's just that the host value has changed because I've used this. If I come out of this, and now if I try to run this, right, this command, it won't work because I am out of cluster. Let me try first. Doesn't work because there's no DNS. But will this work? Let's try that out. Yes, it does because I'm directly using IP and it's part of the network. So if I check the root, right, for this, I see that the root is already there inside inside this node. So hence it was able to move to the pods. So these were a couple of variation when I'm trying to access internally. Since I have HTTP configured, I am using HTTP protocol. If I'm trying to access via ingress, I have certificate configured, so I'm using HTTPS in that case. All right. And since I do not have a domain registered, hence I had to use the host header. And we have also seen that the logic of remote address. One important thing that you should always keep in mind is that if you want to do internal communication, that is pod to pod communication, there's no point of going via ingress. You can directly use the SVC cluster local domain. You can always form this URL. It's simple, right? App name, you always know your namespace, which is the environment ID, followed by svc.cluster.local. The reason behind this is that the ingress will basically rewrite the TCP connection. So when you send a request to ingress, what it does is it it rewrites, it takes that request and creates a new TCP connection. So there are two TCP, one from the curl agent to the ingress, and the next one is from ingress to your mule application. So there are two TCP connection instead of one. So that adds latency. So in case if you want pod to pod communication, right? So to reduce the latency, you can simply go with this URL, and this is the suggested approach because you get better performance. All right, with that, we complete the ingress part for RTF appliance. I hope you found the video useful. Thanks for watching.